Basically, every object in the beginning has the pointer to the Vtable. And Vtable is basically a table of function pointers. So each slot accounts for one function, and then compiler generates the code to invoke the virtual function by looking the pointer of that method from the object headers table.
Hello everyone, welcome to the Game Engineering Podcast. Today I am joined by Wojtek, the creator of Flax Engine, which, as it was once described, is like Unity and Unreal had a baby. It has a source code available on GitHub, and we discuss in this episode a couple of its amazing features. And this is highly technical video. Wojtek walks me through an incredible low-level hack that relies on the assembly instructions generated by the compiler in order to work. If by now you're tingling with excitement, you know that you've come to the right place. Enjoy the show.
So Flax Engine is a complete game engine with editor tooling, everything that's needed to build the game, including 3D graphics, physics, navigation, AI tooling, all the content processing, scripting support that is needed by the game developers to create the game project that can be shipped and sold in game stores. Flax Engine is a small engine, and that's our advantage over the big ones, the Unity and Unreal, since we use it as our agile base where we can quickly develop custom solutions. We are very happy about the core foundation that is very stable and helps us to bring new stuff into the engine very quickly with a small team, which is our advantage. Flex Engine can be described as an engine somewhere in between those two I mentioned, Unity and Unreal. We don't want to follow each one of them. We try to build our own sweet spot in the middle, where we believe there's enough place for another one.
I think there was a quote, I'm not sure whether it was from you or somebody from the internet, that Flax Engine is like Unreal and Unity had a baby, right?
Yeah, exactly. I think that was commented by someone on one of the early videos, I think, on YouTube, and then we use it as our funny quote, but also a good summary of the idea where we are trying to get. We were building a very unique experience for the game developers that of course I'm gonna explain a little bit more in details later on, and I think the good example would be to say how, for example, scripting works in Flax, where we have, like, for example, C# scripting in Unity and C++, like Unreal, and this gives us opportunity to very quickly convert any Unity or Unreal developers, convert their experience into Flax Engine, which roughly means it's like an hour for the developer to convert into Flax their experience and start working with it, make great stuff.
Yeah, and before we dive into more technical details, maybe let's talk about the licensing that Flax has, because I think it's an important aspect.
Yes, so Flax Engine uses a revenue share model, where we account for 4% of the revenue from game sales over the 250K per calendar quarter dollars. So if game reaches revenue that goes above that value, then the revenue for 4% starts to count. Anything below is basically free. So this means the engine is free for the, of course, uncommercial use and educational use. But for small indie developers, especially solo devs, in most cases, engine is free to use. And this licensing model basically promotes the games that are successful, that made the sale and get nice revenue, and then the money pours to Flex as well. So our goal is to make people uh, features that can be used to build great games.
Yeah. And for the code part, it's open. You can find
Yes,
open code on GitHub,
exactly.
right?
Yes, it's public. Source code is released. It's not open source. That's important difference. And the public source code is a big advantage, especially for our community and contributors who can actively work on that one too and use it.
Okay. And maybe you can tell me a little bit more about the why you decided and when to build Flax Engine.
Well, let me tell you a story. So it all started over a decade ago, I think. Yeah, 11 years ago, something like that. I was in high school, and that was basically my side project after hours, to learn some graphics, computer graphics, and learn about physics, simulation, how it works in games. Previously, I used some Unreal Engine 3 at that time and made some small games, Unity 3 and Unity 4 later on. So I already got some game dev experience, but I wanted to build my own game framework for this purpose. And that started as a great experience. And initially, there were like very rough things slowly working on. And over the time, I started the IT studies, and the project still continued at pretty fast pace. Uh, and later on, at some point, I saw the opportunity for this to be a commercial product, since the engine started to be in good shape. Like all the parts were coming in, and
How much? How
I
many? What was the time? How many years it needed to, as a side project, to become like a valuable in terms of like commercial aspects?
um, I saw the opportunity for this after at least 4 years, 3 4 years, I think. Especially because during that time around that, I took a break in studies and went to Tokyo, Japan to work on another game engine as a job. It was a Zenko game engine in Silicon, developed by Silicon Studio, Japanese company. And I worked there on some graphic stuff, optimizing shaders, writing some texture streaming and systems for the game engine. It was C# game engine that now is known as a Stride game engine. It's open source after a company released it for free and stopped developing actively. And at the time, I saw that the project I developed at home was pretty neat compared to the thing I worked there for, like real money with real team. It was like several people working on just this game engine with some clients already. So I thought that's a good direction. Yeah, I can use it. I don't need to be just a side project, because until this moment, the main focus was to learn and to try new things. I remember vividly when I saw, for example, a feature in a Witcher 3 game, and I really wanted to implement something similar in the engine, like screen space reflections on the water that made it look nice. So the next day after playing the game, I jumped into the engine and started to prototype something. Um, at that time, I also learned a lot about reading publications and scientific papers from the graphics stuff, where other people explain how they achieved a specific rendering feature, for example, or something in the engine. Um, and
Is
this
this,
give, gave
let me interrupt you. Is this a big source of information for the graphics part?
Yeah, I think yeah, that's definitely useful. Another would be the GDC presentations and other conference presentations, where basically developers, usually from the graphics, since it's very visual and can be very competitive to show new features, showcase their own knowledge. What they do good, what they do bad, their mistakes and their successes. So success stories. So I always like to read those and learn from their their stuff.
Okay.
and this helped to bring new features into Flax Engine by developing on tech there. Um, so at this point, I came back from Japan to finish studies because I knew that if I stayed there for long, I want to be bachelor and want to finish engineering. Um, and at that time, I started to transition myself a little. Like if I get a new job in a game dev, sometimes I schedule my time to work a little bit more on the engine, not full-time jobs, to just be a little more committed into engine. I knew that it's pretty hard, mostly because of the complexity already at that time, and it turned to be even more complex task later on. Um,
And
but
this is also in terms of complexity. This is complex because it's a general engine. Like it's not an engine for a given game where you know the requirements, but this is a general project and it's supposed to handle any kind of type of game, right?
yes, exactly. That's definitely an important factor. Um, Flax Engine is more like 3D engine tailored into this area. Um, we don't aim to do right now that much, or at least don't have that much tooling for this area, which would be even more a challenge for us. Uh, but of course, like developing a game engine for a specific game like Minecraft or a tier-down game, voxel destruction, I suppose it's a little easier, or at least you're more focused on a very specific game feature that you need. But to be honest, the game dev market changed a little during past decade.
Okay.
Um, like 10 years ago, it was very common that companies had own in-house game engines with many examples, even from here from Poland, like 11-bit Studios, CD Projekt Red got own engines. Um, that was very common to use once, develop uh, internally. But during the past years, we've seen a big shift towards using ready-to-use engines like Unity and Unreal mostly, but also CryEngine at the time. There's a Godot engine. So companies are trying to optimize this and basically fire the engine and development teams, instead hiring engine developers to maintenance and improve the existing engines,
Yeah.
which is pretty common.
I interrupted your story a little bit. Sorry about that. We were talking about the development of the Flax engine, and you were coming back to Japan. You were doing game dev work and part-time work on the engine, right? And this is
Yes.
to locate this on the time scale. Where is it?
Yeah, it was, I think, 2016,
Okay.
uh, something around
Okay.
2017. Because later on, I started doing some public work on Flax to share my stuff with the world, and the public alpha and beta started. Initially, it was, I think, closed tests. Yeah, I think it was closed tests. We got our own small account system where people can get the invite link, and with that invite link, they could register account and get the engine to be used. So during alpha and beta stages for like 2 years, we've got several hundred people using Flex, and that was our like way enough for us because we got enough user base to get nice back reports, to have enough time to work on specific stuff for those people. But at that time, engine was very rough. I would say only the very small projects survived to be released with it. And that was a great lesson to me that game engines are very complex, especially generalized game engines, like you said. So it takes a lot of time to build all the features and all the tools to be properly connected for the whole experience for the game developer. And later on, I started working towards like first public version 1.0 of the engine, and that was released in December in 2020, I think. Yeah, and that's basically how the story of Flax started to be more open, more flourished because we released source code to be public at the time. We started very rapid game development because the team grew over the course of years, and now we are waiting to release another big version. We're actively working with lots of contributors. We have many games in production, and we're excited for the years to come.
And about the contributions, when did the people started to contribute, and in what way into Flax Engine, and how you schedule and like organize the work in terms of other contributors?
So my first contact with contributors from public that were devoted to do something for Flax was during this alpha and beta stages. Some of the people who got the access were actively interested into improving the engine. Like at that time already documentation was public and open sourced. Documentation has a little different licensing because it's just a text with images. We want to be more open for that one. And we've got contributors who want to write the documentation for the engine and spot mistakes help us to build it. And similar for the engine, where we got lots of information how we can improve. And those people were very dedicated, were actively communicating with us. We already got a Discord server and forums where people can discuss and talk. And of course, the biggest moment was 1.0 release when the source code went public and everyone could download it and build and of course improve with contributors contributions. So currently we are like over 5K stars on GitHub. I think way more even. Our community is quickly growing at the pace at the speed that's pretty acceptable for us to maintain it. Because, for example, last year when there was a Unity runtime fee announcement, basically Unity Engine announced different licensing terms for the games, and that were very bad for the many developers. That resulted in a massive flood of users into Flax. So we've got real-time experience how it's to maintain a bigger engine with lots of users submitting bug reports and feature requests.
Can you quantify a little bit how big was the influx of new people interested in Flax? Like, what were, for example, the issues? How many issues were there before and after, something like this?
I remember from website analytics, we've got at least 20K new people joining within like 2 weeks or so.
Okay.
This accounted into a few thousand downloads. At least 1K users on Discord channel was basically added, and we have a bigger community since then. Regarding bug reports, I think it was several hundred. Usually we have something around 1 or 2 pull requests every day merged, and 3-5 bug reports every day submitted. At that time, that was way larger, like 2-3 times more, which was of course good because we got nice feedback. And actually, that was a moment last year, September, when we got nice feedback about the engine feature set. Lots of people were basically saying, "Man, that's a good engine. You've got enough features. Like I could move my game project, I could start another game project with it." But the basic need for the users was the stability and the usability of the editor and tooling. We saw that we lack in this area, and since that time, we've been mostly focused on improving editor and tooling and making whole the ecosystem of the engine more stable to ship the games with it.
And when you say stability, you mean like that from one release to another, there are no breaking changes, things like
For
that?
example, but mostly the engine is stable in that way it doesn't crash. It
Okay.
allows to it allows to complete a whole day of work without crashing the editor. There's less problems with gameplay systems, like less bug reports to be reported. So in that way. The stability is very important, and usability comes from the editor, basically, where people expect all the tools they need in one place. And that's basically is the last point for the thing I wanted to say about the complexity of the game engine. I think that's one of the main reasons, or probably the main reason why so many companies are shifting from in-house engines to ready-to-use engines, to commercial product, because it's a very complex task to build a game engine. Uh, you can get it probably from the story, but also from the examples, like Silicon Studio company who got the Zenko engine. They basically stopped developing it. It was not viable. A few years ago, there was a company called Our Machinery, I think, and they small team from Sweden, a few people, and they developed own game engine in C language, and they failed. They basically stopped doing it. It was not viable. Uh, Competition is pretty hard, I would say, but time to develop the engine that is complete enough in terms of features, stability, and usability of tools is a very complex task, and there's always something that people need to be added, and that's why in-house engines failed to basically in this to follow the race where developers in in-house studios like in commercial game developers were using own engines, and artists, for example, requested a specific feature to be added because they knew this feature exists in different engines. So developers maintaining the in-house engine got to basically follow the other engines, and there was less time to focus on custom tech developed for a specific game. And that's why many companies decided to just screw this project. Let's use ready-to-use engine. The licensing is not that bad. It makes the costs, and that's how the game engine market changed.
Yeah, and if that's complex, if it's complex to build an in-house engine, I assume it's also complex to manage different contributors working on a public code Flax engine. So how do you schedule the work with the contributors that are actively maintaining and developing some parts of the engine?
Yeah, that's actually a challenge. At least we are in a place where we don't have that massive flood of users, like for example Godot has, where they have thousands or hundreds of thousands new issues every week. For us, we are a small team, as I mentioned in the beginning. Um, in the past, I did all by myself, but over the time, as I mentioned, we got new contributors, and also people who want to work a little more, and developers of the engine who are very committed to the specific parts of the engine. For example, one of the developers maintains and works on C# scripting and scripting performance in general, improves the tooling of the .NET we use. Another developer is focused on editor, specifically on the usability of editor, improving the appearance, improving the tools and features there. Another one is working on documentation part and community management or engagement, especially. So we're starting to have specific roles in a team, but now it's like we're working on very non-formal environment where I don't push specific things on people to be done, more like guidance where we want to reach, where we want to go, the directions. We have public roadmap of the engine. That's very important to us because it helps us to plan the workload for future. Um, every few months, I update the close plan for us to work. I lay out specific features and timings when we have to do something, and that's based mostly on the community requests. We very take we hear people on the Discord and forums. We listen to their needs, and that's very important to us. For example, for the last milestone that was done in the end of the previous year, we've got scheduled a few new features like video player, improvements to the GI, and I think a little more. But since the usability and the stability was a
GI,
pretty
GI meaning global illumination, right?
oh yeah,
Yeah.
sorry, yeah, there's a global illumination, and since usability was highly requested by the community, we basically said, all right, we don't want to work on new features. We have to listen, you guys, and uh, basically we move all the new features from that milestone that we worked in future in this year, instead focusing on our users' needs. Um, so
So
the planning is
yeah,
pretty
yeah.
important, but it's non-formal right now. We manage on direction, not the specific day-to-day tasks.
Okay. So there is a public roadmap from which you derive the more closed plan in terms of actual contributors, like
Yes.
direction of different kinds of things and focus, and contributors in a kind of distributed manner access this closed plan and derive the work for themselves. You don't do any meetings that would be like involving in a synchronous way everybody's
Yes. Sometimes we have with developers small meetings,
okay.
but very rarely. It's very non-distributed system, as you describe right now, how it works. But yeah, usually people request a specific feature or bug, and one of the contributors who works in this area jumps into the topic and submits the fix. Um, for example, currently I'm doing a code review in terms of merging code into the repository, but other developers also have access, and they do they can do it as well.
Yeah, I think that's great. Like you said, non-distributed. I think it's quite distributed. Like you give a lot of responsibility for the people that maintain and develop new features, and uh, you kind of don't need to worry about everything. You give them, okay, here's the direction now. Like use your knowledge and learn and think, okay, what would be the best to accomplish this goal? Like there is another part, it's like a micromanaging part where you would be like, okay, you have to do this and then this and then this, and then for the other person, okay, you need to do this and then this and then this, and you would drown yourself in work and nothing would be done because you would need to, like, change the plan and things like that. I think that's a great way, like, to hand over also the responsibility. And people like to, like, if people are serious, they like responsibility, and they want to have, okay, this is my part, and I want to understand how to accomplish the goal that I need in the best way. I think that's a great way to schedule this work. It's really nice. And
Yeah.
how many contributors now are there? It's like between 5 and 10 or more.
Um, uh, to the engine, there was like at least 70 people contributed
Oh,
over
okay,
the course of a few years. But when it comes to core contributors, the team is just a few people.
okay,
The developers, like 5 developers team, and a few core contributors that actively push stuff to the engine, mostly based on their needs or direction they want to follow exactly,
okay.
as you said.
So let's talk about the engine in terms of features a little bit. We mentioned that Flax Engine is somewhat in between Unreal and Unity. And what would be the why would anybody choose Flax Engine over the other engines? Like what Flax Engine has that is better in terms of Unity and Unreal.
Yeah, so our main goal and my main key selling point of the engine uh, is agile development process that is being tied into the engine everywhere. Our key goal is to provide as fast development as possible. This accounts for a quick iteration of the project. Every action that developers perform are meant to be very fast and instant. Uh, all the tooling is meant to be already there without need to wait or grab for anything else. So um, we aim for very rapid development where developers don't need to be bored with their work. The games are fun, so development should also be a little bit more fun. So to make this process easier for everyone. And for example, as I mentioned in the beginning, that there's example of the scripting language, and that's exactly one of those where for example, where the developer of the Unreal Engine, or the one who creates games in Unity, can very easily transition their experience into the Flax and start building from basically after an hour of using Flax, you can already build something interesting and got your hands dirty with all the features. And we see that people basically say that, yeah, that's fast. That's what I needed in terms of something fresh, something new, and that's our area where we built Flax Engine. One of the good examples would be also that the foundation of the engine is very stable, and the features that we want to build are divided into two categories, I would say. One is the core features that specifically need to be in the engine. For example, vertex painting or the cloth simulation, physical simulation. We believe it's like almost every game, 3D game, gonna use it. So we want to have it in core engine. Whereas there are features that may not that be useful by every game, but still gonna be useful for the game developers, such as gameplay framework for shooters, or Xbox Live integration for the achievements, or Steam integration for Steam platform. So many games might use it, but not every. That's why we develop those features as a public plugins to be downloaded and added into the engine as a developer needs. This means that over the course of the years, and as I said in the beginning, like engine development is a long process, right? The Unreal Engine has like lots of years, 30 years over. So during that time, the engine grows, which is natural way. And we don't want to bloat the engine with things that are not needed, because then we have to maintain those and also take care in future. So that's why we try to keep the foundation of the engine very slim, very agile for those specific needs, whereas some features are developed as a side things, as a plugins, for example, to be pulled in. And we built different things in the editor using the same paradigm, like the scripting. As I mentioned, we have this C++ scripting, C# scripting, and visual scripting. And I believe that that gives lots of opportunity to different developers to use their own knowledge, the skills they already have, and pour them into the Flax engine without thinking, like, how much time do I need to learn something new? And this is supposed to be very easy to start with. For example, we have a custom hot reloading for the scripting code. It's a very nice feature that allows us to very quickly refresh the scripting. Basically, it unloads the previous scripting stuff and loads a new code as a developer writes new code, which helps to very rapidly prototype the game in editor. You don't have to close the editor, you don't have to rebuild anything or recompile. Everything is done under the hood, and it's very instant, as our key goal is. And that's one of the key features of Flex, where developer can write a small script in editor, in code editor, change one variable, one function, click Control S, and gonna see the immediate response on editor that code is updated. Whereas in Unity and Unreal, this process is very slow, and usually developers are not happy about it.
Yeah. And I used Flax Engine for a little bit. And first of all, if you have Unity background, you will be you will feel at home, because you have a lot of similar, at least visual look and feel situations. Mentioned scripting language. So the Flax Engine is built in C++, right? But the scripting language that is used where you write scripts for moving things and behavior for your game and gameplay. This is done in C# scripting language, so it's pretty. That's exactly how it's done in Unity. And apart from the C# scripting language, you have the visual scripting language, right? So yeah, and the hot reloading part. Do you know whether in the bigger projects is it more slow? Does it become slower in terms of when your project grows, or it remains at the same speed for the hot reload?
It's definitely pretty damn fast. We got a few projects that are bigger, specifically the ones that use a lot of plugins, or the code base is not just one big library with game code, but like in the bigger companies, engineers tend to split their features they code into different things. Like there might be one library that handles matchmaking for the online game, another code base for the debugging tools. So the project quickly grows with lots of interfaces talking to each other. And we see that in those projects, the gain is pretty significant. We still are able to hot reload pretty fast. This was the big change for us was upgrade from old C# because we used the Mono project. Mono project is an open source implementation of C# language that was maintained by the community. And later on, it was bought by Microsoft and made it managed by Microsoft because they said that, okay, C# is patented, but you can use our APIs and implement it publicly. And that's the same scripting backend that Unity uses, for example. But some time ago, Microsoft announced a new .NET, .NET 5, .NET 6, .NET 7, and so on. And during that time, they started to open a lot of internals of their .NET runtime. And at .NET 7 last year, one of the contributors implemented the whole C# runtime using the new .NET. It's called Core CLR. And we use it basically for everything. And it's the same C# runtime that all the C# apps are running. That accounted for large performance benefits because it's using the latest stuff from Microsoft. And the hot reload specifically got way faster because previously we used our custom tech to handle dynamic libraries reloading with lots of internals being touched, and that results sometimes in crashes in editor, which was a bad problem for customers due to this lack of stability, as I said. And now with the new hot reload, that's very, very fast in editor. And that's another advantage over Unity, for example, because Unity is still using old Mono project and old C# version from a few years back. And they're a very big engine. And the problem for them is to transition to something new, the new technology, because the code base is large, the team is very large, they have lots of dependencies. So our advantage is being the agile slim engine, where we can make those decisions and implement those way quicker. And in that case, it was even done by one of the contributors, one of the developers. So it shows how Flux goes in this area.
How flexible is Flax Engine?
Yes,
Okay.
exactly.
Okay, let's dive into more technical things. For everybody who's listening, I asked Wojtek to prepare or like to select a couple of things that we can talk about in more detail in terms of technically, because we could talk about things technically for like 10 hours and we don't have that much time. And one of the things that we chose to talk about is how scripting work. And in general, I'm really interested in learning how, in general, scripting work, because there's this C++ program that is running, and you have another part that is written in a different language, and they need to interact somehow. And there's this also part of like reloading and adding new stuff dynamically to an already running program. And let's say it's not obvious. If you don't think about it, maybe it's obvious, but if you start to think about it, it becomes complex. Like how one code written in a different language would know what to call in a different already running program. So can you tell me a little bit more about how in general this works for different kinds of engines, and how is it implemented in Flax Engine, the scripting part?
Yeah, that's a good question. So let's say we have engine in C++, like Unity, Unreal, or Flax, and we have this scripting backend, which is kind of black box for us. In Unity, it's a mono runtime for the C#. In Flax, we have .NET that runs C#. In Unreal, there is a Blueprint system, a virtual machine that also runs the script, and it's, let's say, black box. So in engines, generally, there is this black box engine, the scripting engine has a feature to invoke a code. Let's say we have function of name update that's supposed to be called on every engine update, game update loop. And we can basically say that, hey, call me that method. I'm gonna pass you some parameters like this one, and pass them to the scripting so scripts can use it. And other way, there is usually some way of binding the stuff from the engine as APIs into the scripting language, whether it's done by the dynamic libraries, which is a common thing in computer systems, or something different. But definitely, there's a way to interact in that direction. So scripting language can ask the engine by the simple APIs to provide some data. For example, when we call this update function, it might need some time differentiate time information from the previous frame. For example, how much time it took to update the previous frame. And using this information, the scripting can decide how much to move, for example, the player object. So those two ways of interaction are usually handled by some bindings generation code. Usually it's like one of the build system tools that build the engine, compile it, auto-generate some APIs binding information. Some people might be familiar from Unreal Engine. It's called like EU macros, like EU function, EU property. You type those macros, and then when it's being compiled, the code, the engine compiler basically extracts those information as a metadata of the script and generates the binding code that helps to talk those two interfaces each other. We have something similar in Flax. It's our own Flax build tool in C# written, and it basically reads the engine source code, engine headers, to find the APIs, and generates the C# code automatically based on C++ code, and links the interfaces together, like implements proper data conversion, because like there might be a different way of storing, like let's say text on C++ and C#. So we want to convert the text from one format to another format. Sometimes text encoding can change. So this is fully automated. That's one of the strong features of Flax. In the past, it was a little harder to connect to scripting languages. Sometimes you had to write by hand a scripting API for C++ and C#, and then write some automated or semi-automated stuff that connected to worlds. But now we're proud to have the very automatic solution that basically reads C++ and outputs bindings that connect those two things. And I mentioned the way of calling the scripting backend, where you ask scripting, hey, give me the update function and call it right now. And that's basically how it works in most engines. In Unreal, when you update the tick function in Blueprint, it's under the hood. It basically calls find function by name and gets the function pointer and calls it manually. In Flax,
okay, can I interrupt you here? So you're saying that when you have a scripting part, like a scripting C# script program, and you compile it, you go to in Unreal, you go to the other source code, not the running program, but the source code, right? And you read the file, and you want to find the function with the given name, and you also see the parameters that you need to supply. So you need to do the conversion from your language, like C#. For example, you have a string, but underlying string implementation might be different than what is called string in the C++, and it is the case. So we need to convert this data into a proper data for the parameter, and then since you can call and find function by name, you extract what is the function, where is it located, so that you can call it from the C# part. And if you convert properly the parameters, it will just work. And that would be the
Yes.
case. Okay.
Yes, in Unity and Unreal, usually they use the find function way of gathering the function to call, and it's being like the scripting backend knows that hey, I'm overriding the update function from the script interface, and the engine knows that it's script interface, it's got update function, so it's gonna find it by the name. So it's kind of automatic, except there always problem with scripting because you have to do this conversion. You have to find this function, and this layer in between can be very slow in some cases. For example, recently Godot engine started transitioning also to .NET from Mono project for C# scripting, and it turned out to be pretty problem for them that this conversion layer in between was very slowly implemented with lots of bad code. And people basically notice that when you have a game and try to raycast through the physics 10, which is check whether there's like collision with another object in a game code. And if you do a lot of those raycasts, the game is very slow. And they looked into the profiling tools and immediately saw that this transition layer in between those two languages is very poorly written. So that's a danger of the of this thing. Whereas in Flax Engine, we got our custom tool that generates very highly optimized code, and we use the lots of like nice hacks in C++ language, since we wanted to avoid this find function call. That's very problematic, especially when there's a object with lots of functions. If like there's, let's say, it's fine for the script with one function, but if the game grows larger, as we talked before, there can be script with 200 functions. So you don't want to find this function every time you iterate over the scripts, and you also don't want to cache everything in some dictionaries, lookup tables, because it's also not so efficient to just look up by the name hash and get the function pointer. So instead, we develop a custom hacky solution over the C++ language, because in C++, when you override the function from the interface, there's a feature called vtables, or virtual tables, and basically every object in the beginning has the pointer to the vtable. And vtable is basically a table of function pointers. So each slot accounts for one function, and then compiler generates the code to invoke the virtual function by looking the pointer of that method from the object headers table. So that way, in C++, you can overwrite a method, and the C++ will call different code. It doesn't matter what object comes in, assuming it's the same interface. So we thought, yeah, that's the ideal solution for us for the scripting. We don't need to find function or something. It's the function pointer is already in the object header. It's there. It's the same code as C++, so it's going to be fast as C++ to invoke the method with very minimal bindings layer. So that's how we started prototyping, and I should have write some tech article about it because it's it's pretty old feature to us. It's like 2 years or 3 years old in Engine, and what it does basically, we do use this find function when we initialize the script. For example, the binary of scripts is loaded, and we search for all the scripts in the file, and we find, yeah, here's my script from the game. It has update function. We got it. So we cache the pointer for it, and we store that pointer in a vtable. basically there's like many in between small C++ method generated for that, but it's being called from C++ directly. And to do this, we basically clone the Vtable memory with some slack before and after, and use some low-level assembly code hacks to find the index of that function in that Vtable and swap the method pointer. Surprisingly, because like the problem is it's undefined behavior. It's not defined in C++.
Yeah.
I know that you had a podcast episode with one of the C++ committee members,
Yeah.
and if you ask him, he probably say that, well, that's
That's
that's not a
illegal.
language feature.
That's
It's
illegal.
illegal. Yeah, it's not defined behavior in the language. It's known feature of the compilers, because that's the best way to implement the virtual function calls. Very common, and it's the same they did for many years. And for the two most common C++ compilers, which is Clang compiler and Microsoft Visual Compiler, they work very similar, but we've got to implement a different hacks for each of them and test those hacks on all platforms. But I can say that this code works on Windows, works on Xbox, works on PlayStation, on Linux, on Mac, on iOS, on Android, on all platforms we are supporting. And those hacks are working. We duplicate vtables, swap the pointers, and put them back into the object header when we create it.
So there is a danger that if there will be a new version of the compiler, this will stop working. Is that right?
Yes.
Okay.
Yes, exactly. That's very dangerous. And usually when there's like preview version of new compiler, new Clang or new Visual Studio, we quickly download the beta version or preview to just check, hey, whether they broke it or not.
Are there? Is this the only hack that does this? Like, is it the only hack of such a low levelness in the engine?
Yeah, because that's known fact that there's vtable in the beginning.
Yeah.
But the problem is how to get the index of the function of the that's in vtable, because um, you don't know what's in vtable. It's just black box. You know that there's like update function that's being overridden. It's somewhere in the vtable. It might be in the slot 1, slot 2, slot 3, and so on. So we got to find it. And to check it, we know that compiler generated assembly code to call that function. So we know that it put in the assembly code the index of that function somewhere to move to the registers. So we read the assembly code
Okay.
to get that index on the Microsoft compiler. On Clang, it's a little different, because if you ask Clang compiler to get the function pointer of the member method, such a very overridden on update, it's gonna return you just an index of that function. So
Okay.
it's easier on that compiler.
Okay. Okay. Have you tried with GCC?
No, actually, we
Okay.
don't support that compiler. I believe it might be something similar to Clang. I hope so. I know that there's also Intel compiler, but we don't support those.
Yeah, Intel compiler. I think it's growing out of fashion in terms of C and C++. Okay, that's so cool. That's so cool. And just to mention, because you mentioned this, but uh, vtables are the way of implementing inheritance in C++. So you're not
Exactly.
supposed to ask vtable for function pointers or
No.
anything. It's for you to be able to create a new class that inherits from the first class and then swap the pointers if you have a new implementation overridden function.
Yes,
It's
and when there's like C++ class in Engine API called script, it has public virtual methods of update. So there can be another C++ script in a game code that overrides it, or another one in a plugin or something like that. But when we create the object for with C Sharp's class that has been overwritten, that update function in C Sharp, we basically, when we create that object, we check if it's from that C Sharp type. If it is, then we customize this vtable, basically duplicate it. So if we duplicate the vtable, there are already overrides of base class. Like for example, plugin script can do something custom. And then we swap that pointer, put it back to that object, and it lives for the own time. And then when C Sharp is being called, that goes over of this vtable. It's a little hacky. We've got lots of
A
crashes initially.
little, a little. You're committed to this hack. Like you've implemented this, see the issues that stem from it, and then you like resolve the issues. Like you're way committed to this hack. It's not a little hacky solution. That's nice.
Yeah.
That's awesome. That's awesome.
I should have write an article about it. I think I'm gonna post it sometime soon with
Yeah.
some code examples, because I think it would be easier to understand with some code
Yeah,
being
and
shown how it goes.
visuals. Yeah,
Yes.
yeah, yeah, yeah. If you do it before the podcast goes live, we can link it in the description also, and maybe put pictures in the episode as well, with like overlaying it visually a little bit. Okay, okay, nice, nice. Let's turn into the other part. Real-time global illumination. So this is the quite trendy topic, right? Especially
Yes.
since Unreal 5 and their demos of a real-time illumination, global illumination. Let's maybe start with a little bit of background, like why is this a big thing? How usually lighting works in a game, and then let's turn to the real-time GI.
Yes. So global illumination is called Holy Grail in computer graphics because it's very hard to achieve, and there's been many decades of people struggling to make it look real and to run fast on computers. And what it does, it's about algorithm that calculates how light spreads in the real world. So in computer graphics, we've got a way to calculate the direct lighting. So if there's like sun that casts light, it goes into a specific surface. So we can calculate how much light goes to that surface, whether it's in a shadow or not. And shadow can be also semi-transparent with some penumbra effects. So we can calculate that kind of easily and very fast. But the problem is that there's light that comes on that surface and it's being reflected. It goes over, like it's bouncing through the scene, and if there are objects nearby, it might bounce on them. And also there's effect of coral bleeding, because if you take a very bright colorful object like red box and put it in a full sunlight, it's going to reflect this red light over surroundings. And that basically that's how the global illumination works. It illuminates globally the light from the objects into each other. Of course, each bounce of the light reduces the energy of it because it's being partially uh, taken by this object surface. So it fades gradually. And the problem of the computer graphics of this algorithm is how to implement it. It's a very hard challenge because the light is spreading very fast. It's hard to estimate it because the light can come from every direction to the every pixel on a screen. And that's why it's been always a struggle for computer graphics engineers to implement it efficiently. For many decades, I think the easiest way was to use some path tracing or ray tracing technology offline and compute the light maps. Light maps are textures placed on object surfaces with already calculated GI for the scene. So then when the player plays the game, they already have lighting cooked in, and they just need to calculate, for example, the direct lighting or just dynamic object lighting. So this was great because we can offline compile all the photons going through the scene, and just output ready to use textures. And the game performance is good. But the problem is it doesn't work for the dynamic scenes because we calculate this offline. So for dynamic scenes, there's been many decades of different algorithms, different way of calculating the light. Most commonly used as a way of doing some kind of light probes. And light probe is just one point in a space for which we calculate the GI. Let's say we have a small sphere in the middle of the room, and we calculate how much light comes to the sphere exactly, and how the scene looks from the point of view of that sphere. And if we calculate this, we could interpolate the value of this lighting on that sphere into the object surfaces in that room. And this allows us to estimate the GI on object surfaces a little. And since we don't have to calculate this for every pixel, and we can keep those light probes in a kind of optimized structure with optimized algorithms going over them, this allows to do semi-dynamic or fully dynamic GI in games. It's been kind of a common way of implementing GI. For example, the game I mentioned before, Witcher 3, used a similar technique to implement dynamic GI, especially when the time of the day changes. There were basically probes in a world that calculate the lighting for themselves and spread this lighting information into the pixels. The problem with this technique is it's not accurate. It just calculates the light for specific objects in space, places in space, whereas over the time the games are growing, the worlds are more complex. The gamers want to play the games that are more realistic, the games that the lighting is better, like spreads more naturally, more realistic, with higher fidelity. So that's why there's constant need to tackle solutions for this problem. And that's how the Unreal Engine 5, as you mentioned, comes out a few years back with a custom GI solution called Lumen. And it changed the world basically from that point on, because they invented lots of stuff. They used lots of papers, public research papers that were already released before, but they managed to connect lots of dots together. Specifically, they used sign distance fields to perform software ray tracing, and they implemented lots of denoising in screen space to reduce the noisiness of the ray tracing. Because under the hood, when we have this light probe in a space, I said the way to calculate the lighting that comes to that probe, the easiest way is to just ray trace through the scene. You shoot the ray into the surroundings and check if it's hitting something. If it's hitting a material, like for example, for that example with the red box, and there might be a probe nearby this, and if one ray from that probe hits the red box, it gives the information that, hey, nearby the probe on the right side, there is red box, red pixel. It's pretty bright, so we have to account for that lighting information. And recently, there's been new hardware ray tracing coming to GPUs, which is a very efficient way to ray trace through the triangle scene and get this information on that color of the pixel that we're hitting on. But the problem is it's not supported on every hardware, only on the newest GPUs. And also, even though it's very fast, it's not that fast to be used everywhere. What I mean, we cannot use only ray tracing. We have very strict budget amount how many rays we can shoot through the one frame of the rendering update. So that's why.
How is it called? Like, how can you check whether your graphics card supports this?
NVIDIA called it RTX.
Okay.
Similar feature came out on different GPUs, and it's supported on also consoles.
Okay, but you're talking about like proper ray tracing support, not like a subset of it with like a special technology. So just the ray tracing support for the graphics card.
And
okay.
The ray tracing support, the ray tracing API allows us to trace through the scene and get this information. Like if there is probe, there might be a red box nearby it. So we can get information that on that way there is a red box. So if there is a GPU that doesn't support it, or maybe there's a different way to ray trace through the scene that doesn't cost that much. And that's how Epic used in Unreal Engine 5 sign distance fields. Sign distance field is a way of representing the objects, 3D objects, usually, but also works for 2D, with a uniform grid of pixels. And in each pixel, we store the information about the distance to the closest surface. The distance can be negative if we are inside the object, so that's why it's signed distance field. And using this data, we can efficiently trace through this field, because at every pixel we know the distance to the closest surface. So if we move this distance for the ray, we know that we won't hit surface, or at least maybe on the end of the ray. So that's how we can very quickly ray trace through that surface. And they added the ability to calculate the distance fields before in Unreal Engine 4, but they use it for Lumen to ray trace the world. Of course, there's lots of technical challenges, like how to, we can ray trace to the scene, but what's the color of that surface we hit on? And how to store this efficiently, because there can be thousands of objects on a scene, and we have to combine them somehow in one ray tracing API. But with this system in place, they could do ray tracing for the world to calculate the lighting coming into the probes. So after Unreal Engine released this feature, we already were before interested in doing some real-time GI for the Flax, because we already had light maps baking, but we didn't have the real-time GI solution. So this was a good idea for us that hey, there's a way to doing GI with ray tracing, but without hardware ray tracing, with distance fields. That was first idea. And the second idea was at that time, NVIDIA released the DGI algorithm, and DDGI is basically a dynamic diffuse global illumination. It's a public paper, scientific paper with good code examples and great presentation. But it's made by some scientists at NVIDIA. And this algorithm basically uses a uniform grid of probes around the camera, and they calculate global illumination for each of those probes. They calculate also the distance to the surfaces nearby, and they can efficiently calculate the per pixel lighting from those probes.
So you have a pointer on the camera, like close to the camera?
Yes, yes, in a very close surroundings.
Okay, and you shoot rays through those points, and then
Yes.
what is the benefit of having those points?
So you have those automatically placed probes around the camera, in front of it, usually nearby the object surfaces, and you perform the ray tracing from those points in space around the probe to calculate the lighting it sees.
Okay.
So we can estimate that, hey, this is probe nearby this red box, which is in a light. So we know that there's lots of red light coming to that probe from that direction. So if we have this grid uniform enough and like dense enough, then nearby pixels that are on a screen nearby those probes can interpolate the results of those probes. So it's using something similar I told you before, except this DDGI algorithm used a small depth buffer for those probes. Very low resolution depth information, how the pixels are close to that probe. And this allows to reject the lighting influence from the pixels that are behind the probe. Because the common problem with the probe solution is that when you have indoor and outdoor environment, like open world game, when the probe is inside the building and another is outside, there's area in between those two probes that is using basically linear interpolation to calculate the lighting values. But the problem is that might be a wall in between. And somewhere in between there might be light leaking from inside to outside and from outside to inside. And to solve this problem, there have been many different ways, but none was so successful as a DDGI, because if we store the depth information in that probe, very low resolution, we can reject the probe lighting information if it's not visible from the pixel. And that helps us to basically reject the lighting from outside probe when we are rendering the pixels inside the building, and use just the values from the nearby probes that are visible to that pixel.
Yeah, I discussed this issue with an environmental artist Tomislav from Crow Team when working on Talos Principle too. like when switching from an outside light with Lumen, Unreal Engine 5, into the labs, which was the indoors environment, and how it was very difficult if somebody stayed in the middle and looked outside and inside. There were lots of graphical issues with that, with light.
Yes, exactly. So in Flax, we took this public NVIDIA paper.
Yeah.
We studied it very intensively, and because the algorithm from NVIDIA used hardware ray tracing, of course, on NVIDIA GPUs to promote their GPUs and to show that it's pretty nice solution. But we wanted to have a more open tag for any GPU without any hardware ray tracing. And that's how we decided to let's implement something similar with distance fields. It's already very common using distance fields in computer graphics, even for the 2D font rendering. Instead of rasterizing font characters into pixels, you can rasterize them into the distance field to have the distance to the font character area, and then rasterize it in higher resolution. So we implemented on SDF, so signed distance field rasterizer, on data storage, and way to build the global distance field for a whole scene from objects inside it. Then we implemented our own Atlas cache, which is a way of rendering object surfaces into the Atlas and projected them on this global distance field. And then with this custom tag, we were able to ray trace for this scene on any GPU and get this information of the light coming in to that probes. It took a few months. After that, we released a public tag demo on Steam. It's available to download for free, and you can play it on your computer. Everyone can test it and check it. It's a high fidelity office space scene with dynamic lighting, where time of the day can change, and the different lighting scenario can help visualize how GI works in Flax, and it's pretty fast.
And you do this after work, like
yeah,
part time. This is how do you have time for this? It first of all, like you do a lot of research to understand how these things work, and then in order to implement it, like it's no joke. Like you need to really understand this, and then go and experiment, do different kinds of things, and then like fit it also beside the work and your like private life. How do you find time for this?
That's a pretty challenge. I have skill to efficiently divide my attention and quickly switch the context. I don't need that much time to continue to pick up my work from the previous day. For example, I can be like straight in the middle of reading some sentence and just can easily come back to the paper that I'm reading or the code I'm writing, and very quickly come back to the thoughts I had when I left off. And this basically helps to like efficiently use just small chunks of time during the day to write the code. For the past months, I've been mostly focused on bug fixing and merging the code and helping others to write their code as contributors help us. So I haven't had that much chance to write my own code. I'm using my leadership guidance for the Flax team, but still, it's kind of challenge sometimes to find enough Slack for everything.
What's the name of the public demo for this?
It's a Flax Engine tech demo.
Okay. Okay, I will put the links.
If you search it,
I will put the links anyway in the description so that everybody who's watching and listening.
Course. There's also a video of it on YouTube.
Okay.
We have
a video. How's it called?
It's Flax Engine tech demo.
Okay.
Definitely.
Okay.
It's gonna pop up.
Okay, tell me a little bit more about the future of Flax Engine. Where do you head in terms of how do you see next year's planning out? Like, is there anything that you want to accomplish in terms of like the place of Flax Engine besides other game engines, or are you like satisfied with how it works currently and you want to like improve it step by step? Is there like a vision, like a goal, North Star that you're heading for?
With Flax, we don't do revolution, we do evolution. So we try to improve step by step different areas, and I always try to divide the attention of developers into all the engine areas gradually. So for example, we don't work only on audio and physics for many months. Instead, we spend some time on audio, some time on physics, some time on graphics. So every area of the engine grows steadily. That's important because we believe that people are using all the features of the engine and expect all the features to steadily grow with feature set. And that's always nice to take a look when someone from community requests a specific feature, and after a few weeks, sometimes few days, sometimes few months, gets this feature implemented into the engine, and like people are happy that yeah, every area of the engine grows. Um, so right now, I would say I'm pretty happy with the stability we achieved during past months, especially last year. Was our goal to reach the point where we are very like confident that you can use Flax Engine, you can make a game, you can release it on Steam, on other store, on consoles, and you can get money from it. We're starting to see first games being released, commercial products on sale with good reviews. So that's a good indication for us. And I think this year gonna be very important. I would expect we see more games being worked on and released, bigger adoption of the engine, and uh, at this point, we'd like to implement the missing bits that might be important for some productions. Definitely, our main goal gonna be continuing editor improvements. That's very crucial for everyone. We're gonna also improve the GI because I work on that for the tech demo. It turned out to be very great, and there are many games using it already. But the problem is there are a few bits that were missing at the time to be implemented. For example, due to time restrictions I had on, and now I'd like to come back to the GI solution and implement some stuff I already had in mind, some stuff I learned over the course of years to implement GI. We have some plans for bigger features like a dynamic destruction system to implement more
What is it?
a way to implement the object destruction in a game where
Oh,
people
destruction, like okay, destroying objects in this way.
yes,
Okay.
exactly, like implement the APIs and scripting support to basically break objects where game scripts can blow up the scene when player uh, drops the grenade or shoots
Okay.
the object.
Okay.
And that's a step into direction of more dynamic games, more open worlds. Of course, always we improve the performance. That's also like one of the key factors in this agile engine I'm talking about. We always want to measure performance. We want to always optimize, and every update of the engine contains some bits of optimizing already existing stuff. Um, that's very important to us, and that's also a thing that we see in some game reviews that hey, this game looks fast and it runs fast and looks good. That's very happy to read. Uh,
Can you share some of the names of the games that were done in Flax?
good example would be the game called No Tomorrow.
No
I can
tomorrow. Okay.
No Tomorrow. I can share a link. It's a small horror experience with GI, and it uses also like upscaling from plugin that we made. So it uses lots of core features, but got also like optional feature from plugin that was important for that game. The whole infrastructure I told you about works, and people are making games with it. Other than that, we have public roadmap, and the roadmap I told you before that we use as a plan base for us is public. People can vote on features. Usually, it's also a subject of a discussion. Sometimes developers link us a specific feature from the roadmap, like they need it, they'd like to have it appear quicker, or they want to add something. And that's when we have feature requests, we usually just straight go to roadmap and put it there. That's one go missing, because I believe that that's the direction we want to follow. It comes from the community, from the users, our clients who use engine, and then we want to use it as a base to
It's smart.
pick direction.
It's smart. And so, where people can follow Flax Engine? You mentioned public roadmap.
Yes. The best way is just Google Flax Engine. We have a main website with all the links. But yeah, public roadmap is a good place to learn about the future of the engine, the direction we are going. The Twitter account or the X right now is a good place to get the information about updates of the engine. We do have forums with actively people discussing different things, searching for answers. And we have great documentation for the engine. If you don't want the engine, that's a good place to start with. We have lots of stuff documented, many tutorials, everything there. And of course, our core place of community is a Discord channel with 2,800 people talking there and discussing different stuff. We tend to be very active there. By we, I mean developer team and contributors who actively post, for example, small pics or GIFs when they add a new feature, or like, hey, people, I'm gonna do this feature. What do you say? Like, should we change some UI of it? Or maybe do you like it or not? People are very open to discuss new things. So Discord is a great place to come.
Okay. Thank you so much. It was an amazing time and amazing experience to learn all about this stuff in such a detail. Thank you so much.
Thanks for a good discussion.
Take care.